Okay, so on Friday, we started working with compound interest problems, and we knew that it was compound interest because it literally had the word compound or compounded in it. And like I said on Friday, there are three things that we need to make sure we focus on. Okay, one of them, if it says compounded continuously, or if it's going to be a growth or decay. All right, what are some words that make you think that it's growing?
Is it compound?
All right, I'll give you a hint. It starts with an I. Increase. Okay. What might be a word that makes you think about decaying?
Oh,
Decrease. Okay. So those are some key words right there. Also, we'll see appreciate and depreciate. If something appreciates, like most of the time homes appreciate, what's that mean?
It's increased.
The value's increasing. Most of the time cars depreciate, so that means their values are decreasing. All right. Our exponential equation is in the form y equals a times b to the x. In this form, a is always your initial value. Which graphically is also the y-intercept. The b value is your growth factor. Now, depending on what that growth factor is whether you're going to have an increase or a decrease, a growth or decay.
Wait, so where it says y and then the minus, is that y intercept or something?
Uh-huh.
Oh,
It's hyphenated.
okay.
If your b value is greater than 1, it's going to represent growth. And if your b value is less than 1, it's going to represent decay. That is important to know. All right, what's base start with? B. The definition of a base is the number being raised to an exponent, right? So notice here, b is your base. So if your base is bigger than 1, it's growth. If your base is less than 1, it's decay. Now this is the basic equation for exponentials. Okay, what we want to look at is to take that same equation and we want to look at it as an exponential growth or decay version. All right, so that version is going to be y equals your a times, instead of b this time, we got some specialty situations right here.
Listen.
Thank you. It's either going to be 1 plus or minus your rate raised to the x. All right, now, there's actually two equations in here. You either got 1 plus your rate or 1 minus your rate. And this depends on whether you have growth or decay going on, of which equation you're going to use. If something is growing, you're simply going to add your rate to 1. If something is decaying, you're going to subtract your rate from 1. All right. And remember on Friday, I said that that 1 represents 100%. So if you think about it, going back to buying a new sweatshirt, okay? You pay 100% of the price for that sweatshirt, right? But then you have to also add in tax, don't you? So that is a growth because it's increasing. So it was 100% as a decimal. So here's 100%. As a decimal would be a 1, wouldn't it? So that's what that 1 right there represents. 100% of what you started with, plus or minus any additional or rate that you increase by or decrease by. All right, 2 of the 3 vocabulary words that we're going to look at today are growth factor and growth rate. All right, Bree, give me the factors of 8.
You called my ear. I don't feel like talking. I got a headache.
All right, Trinice, what are the factors of 8?
It's maybe this one. Is it 8, 16?
All right, 2 and 4.
Oh, that 2, 4.
1 and 8.
1 and 8.
Okay, congratulations.
Okay, so factors are what we multiply to get that answer, right? To get the product. Okay, so when factor is something that you have had to deal with multiplication. So the way that I look at a growth factor is I look at the multiplier. Okay. And basically, it's just your B value. Now, majority of the time they call it a growth factor whether it's increasing or decreasing, but sometimes you'll see it's written as a decay factor too. But they generally just call it all a growth factor whether it's increasing or decreasing. Okay, so if you think about it, right here, your base is b to the x. If this was b squared, that means you would say b times b, right? You're multiplying b by itself twice. Okay, so that's what I mean by a multiplier. It's what you're multiplying by. Okay, the growth rate. All right, rate we usually think about as some kind of percent. Okay, the growth rate is the amount by which it grows or decays. Okay. What is your tax rate right now? Nobody knows the tax rate? When you go to buy something, how much tax do you have to pay on it?
10 or 7 cents. Most of the time it's 7 cents.
All right, 7%. So 7 cents per dollar. Okay, so if I ask you for the growth rate on what you buy, you would say 7%, right? Okay. All right, so you go, it's the end of the season, the spring stuff is getting ready to come out, so you want to go buy that Nike hoodie, and it's 30% off. All right, so how much are you saving?
You're saving like
What percent did I just say?
30.
30%. So that is your decay rate. So it's also, again, they generally call it a growth rate, but it could also be a decay rate. Okay, so it's the amount by which it either grows or decays. All right, if you're asked to find it from an equation, all right, when you're subtracting things, it's always the biggest number minus the smallest number. So if it's growth, you're going to simply come in here and say your B value minus 1. If it's decay, you're going to say 1 minus your B value. And again, that 1 is coming from 100%. It's 100% of what you started with. That's where that 1 comes from. All right, so everybody got this copied?
Yeah.
All right, so flipping over to the back side. All right, example 1 is asking us about identifying the parts of the function. Okay, so notice this right here. This is 4 times 3/5 raised to the x. So that's a times b to the x. Okay. All right, so look at your b value, everybody. What is your b value here? It is 3/5.
Yes.
Is that bigger than 1 or smaller than 1?
Bigger than 1.
It's smaller because you've only got 3 pieces out of 5, right? So it's smaller than the whole. So that's smaller than 1. So since it's smaller than 1, since 3/5 is less than 1, is that growth or decay? Decay. All right, your factor. That is the b value. So in this equation, what is your b value? 3/5. All right, the rate, bless you. We're going to come right here, we're going to say 1 minus 3/5. Okay, now you could use the calculator, but we're just going to use common sense. If you're getting rid of 3/5 of 3/5, how much are you left with? If you got rid of 3 pieces out of 5,
So you're getting rid of 3.
you're left with 2, so it would be 2 out of 5 or 2/5. All right, the initial value is your a value. So in this problem here, what is the a value?
It's 4.
It is 4.
It is
All right. Well, we also know that that is also the y-intercept, isn't it? So when I go to graph it, where is it going to cross the y-axis? At 4. So 1, 2, 3, 4. I'm going to go ahead and put my point right there because I know that's the y-intercept. All right, so I'm going to graph this. All right, so I've got 4 times 3/5 raised to the x. All right, so here's the shape of my graph. Now, we always read a graph from the left side to the right side. So what is happening from the left side to the right side? It is what?
It is decreasing.
It is decreasing. Okay? Now, of course, my graph is not as pretty as that one, but... Okay. Now, notice how this graph approaches the x-axis, but it never crosses it, does it?
Oh, so it's
Okay. So this is our last vocabulary word here. This is what we call an asymptote. Okay. All right, an asymptote is an imaginary line the graph approaches but never crosses. And for all the ones that we're looking at today, your asymptote is going to be your x-axis. All right, so looking at b. Again, it's in the form a times b to the x.
Yeah.
Okay? All right, folks, is this a growth or decay problem?
It's a growth.
It's decay because 1/3 is less than 1, isn't it? So that would be decay. All right, so what is your growth factor? 1/3. All right, to find your rate, we're going to say 1 minus 1/3. So, Justin, if we're getting rid of 1 out of 3 pieces, how many pieces are you left with?
It's 2.
It's 2. All right, and finally, what is our A value? What's our y-intercept? 1.25. Okay, so again, I know that's my y-intercept, so I'm going to go ahead and at 1.25, I'm going to go ahead and put that point up there. Now, since this is decay, decay is always going to have the same shape for the graph, unless it's been reflected. It's always going to start high and end up low. Okay, so we're starting high, and we're ending low. Now, I'm just doing a generic sketch. I'm not being, specific. The one thing I do know is where it crosses the y-axis. All right, so let's start with Maya and work our way through everybody. All right, Maya, for C, what is is it growth or decay? It is growth. How do you know it's growth?
Because 4.3 is
4.3 is greater than,
32 cents.
it's greater than 1.
You know.
4.3 is greater than 1.
Yeah.
All right.
Sure.
Your factor. What is your growth factor here?
4.3.
Right. Is your B value, which here we got A times B to the X, it is 4.3. All right, Trevon, for your rate here. Ooh. Ooh. I know I didn't say Trayvon. Trayvon says right there, 3rd period. All right, Trey. How do you find your rate? All right, you got to do 4.3. What are you going to do with that 4.3? Look at the front side of your notes. We got to subtract 1. So we get 3.3. Now, a lot of times when we're given a decimal, we change it to a percent. So moving that decimal 2 places, we actually end up with 330%. So it more than tripled the value, didn't it? All right. Trinice, what's your initial value? 0.32.
And this,
Uh-huh.
so how did you know it was 330%?
All right, because here we got 3.3, and when you're changing it from a decimal back to a percent, you move it 2 places to the right.
How would you know it's zero there?
Because if you have an open space, it's an insignificant number, so you put a 0 there. But it becomes significant then.
I don't know because I don't want it.
Basically, if there's a blank, you gotta put a 0.
Thanks.
All right.
I love it.
All right, so 0.32 is gonna be right about there. Now, let's look at what happens with the shape of the graph when it's a growth problem versus a decay problem. We've got 0.32 times 4.3 raised to the x. All right, as it's moving from left to right, what do you notice it's doing? It is
Increasing.
increasing. So
Alright.
your growth problems are always going to have a shape like that unless it's been reflected. So here, it goes along the x-axis and it hits that point and it starts going up.
Miss CP. Can I do the next one?
Abraham is up next.
Oh, it's not like what?
All right. Is growth or decay? growth.
All right.
All right, and we know it's growth because 1.10 is bigger than 1. All right, Genesis, your factor. 1.10 because it's always the B value. All right, Josh, your rate. So that gives us what? Mm-hmm. Which, when we move that decimal 2 places, what is it as a percent, everybody? All right, Chad, what's your initial value? You should get an A on this if you get it right. Shh, don't shout out the answer, anybody. Give him a chance. A little thought might give you a correct answer.
It's. I just got it. Like literally.
Give Chad another minute.
What you ask?
I'm asking for the initial value.
Look at C and then you gonna see what the initial value. Look at it as if.
Help me out, folks.
Hey.
A.
Hey.
Oh. Yeah. Yeah, because this isn't still in the form A times B to the X, right? Okay, so yes, you had a tricky one. Okay, now, since we don't know what A is, we don't know what the y-intercept is, so can we look at the graph? No, but what I do know is that your x-axis would still be the asymptote. It would have the same shape, and we just don't know where it would cross the y-axis. So that would just be an A right there. All right, for all of these basic growth and decay, your x-axis is the asymptote unless there's been a shift. You remember, like if we had right here, if I put a +5, it would go up 5 units. If I put a -5, it would go down 5 units. So that's the only time it changes. Okay, but we'll do that in a couple of days. Okay. So A is just a generic variable for the time being. All right, notice for E and F, it's a YT.
We always move the decimal 2 places.
Miss, CP,
Uh-huh.
what are the days you
Usually Tuesdays and Thursdays.
Sounds. Alright. I'll be coming tomorrow.
Tomorrow I'm not going to be here after school. I got a meeting, got an appointment to attend.
Is that because I said I was going to be there?
Yep.
Okay. I'll remember that next time.
All right, let's take about 2 minutes to do E and F for me real quick.
Hey.
Yep, a little U try here for E and F. Don't trip over that cord.
Oh. Yeah, I'm just forgetting.
Okay, that's who to go. All right.
Hold on.
Okay, Justin, you were next in line here. All right, for E, is that growth or decay?
It's growth.
Thank you, Justin. Because 1.005 is bigger than 1. All right. Alexis, what's your factor here?
You got worksheet on this.
It's big.
1.005.
Oh, I'm sorry.
All right. Amir, what's your rate?
Alright, so your weight is oh, it's 0.005.
All right, because 1.005 minus 1 gives us 0.005. But when we move that decimal 2 places to change it to a percent, it becomes 0.5%.
Didn't we really close, man? I said 0.8.
Landon, what's your initial value?
I did. You didn't.
All right, now 4.4, so that's 1, 2, 3, 4.4 might be right about there. It is growth, so I know it's going to look like this and then go up, right? So it's going to come up and go through 4.4 as the y-intercept. All right, Bree, is F growth or decay? Very good. And we know this is decay because 0.7 is less than 1. All right, Jillian, what's your factor? 0.7, because your factor is always the B value. Let's see, I think I've got everybody now. All right, so everyone, how do you find your rate? 1 minus 0.7. So what's your rate? 0.3. As a percent, it would be 30%. So you're getting rid of 30%, but keeping 70%.
Wait, so how did you get 3?
1 minus 0.7. $1 minus 70 cents is,
Oh, that's oh, you said that.
all right. Everyone, what's your initial value?
Oh, you did it.
1.3. So here's 1.3.
I get it.
It is decay, so that lets me know it's decreasing. So it's going to start high and go low, crossing through 1.3.
I still don't see an A ball on my phone.
Yes,
What are you
ma'am.
doing over there?
Brushing my hands.
Uh-huh.
Oh, but I am.
All right, so G, we're moving into the word problems. Okay, so we got the Johnson Company calculates the value of its stock each year using this formula. All right, here's a typo I made. X should be an exponent right there. Okay, so it's basically asking us
It's
to
a decay.
find the same thing. All right, how do you know it's decay?
Because 0.98 tenths is less than
9.98 is less than 1. What's your factor, everyone?
0.98.
So if you're keeping 98%, what did you get rid of? What percent did you get rid of?
So you got
0.02, so moving that decimal will be 2%. So again, you're keeping 98%, so you got rid of 2%, because percents are always based off 100. What's your initial value? 120. Now, in the little graph that I have right here, it only goes to 6, so we're just going to do a generic graph right quick. All right, right here is our y-intercept of 120. It's decay, so that means it's starting high, but ending low. All right, so can everybody identify the parts of this function? All right, on the back side are our last 2 examples, and this is where we're moving to our applications. And applications is just a fancy way of saying word problems. All right, here we've got Natalie starts a walking program. She walks 2 miles the first week, then each week she increases her distance 5% per week. Write the equation and find the distance she walked for week 10. All right, so y equals, all right, a times. All right, how do I know if this is a growth or decay problem?
This is 5% per week. She increases her distance.
Right, that's the word I'm looking for. Increases lets me know it is a growth problem. And since it's a growth problem, it's going to be 1 plus your rate. All right, so writing the equation is the first thing they want us to do. So A represents our initial value. What was the initial amount of walking she did?
She did 2 miles.
2 miles. So in place of A, I'm going to put a 2. All right, what is our rate?
It's 5%.
All right, so as a decimal, 5% is 0.05 to the x. All right, now, what is, if you had $1 and then I gave you 5 cents, how much money do you have? $1.05. This is the way that you would usually see the equation written in its simplified form. So we got the equation out of the way. Now it's asking us to find out how far she is walking in week 10. All right, that 10 represents your time, which is your x.
Justin. I'm sorry.
So in place of the x, we're going to put a 10. So we got 2 times 1.05 raised to the 10th. So week 10, she was walking about 3.3 miles.
Okay, so for it, you don't use the 10. You don't use the 100 equation, you just use the 10 equation.
It varies.
Wait, so 3.3 miles?
Mm-hmm.
How did you get it? I didn't see that.
You just put it into the equation.
Why would you put it inside the calculator? Oh, so you just put that and then you put it over the This is actually not that bad.
All right, example 3. Our last example. All right, you got a new car for $16,000. It depreciates 12% per year. They want to know what is the equation and what is the value in 3 years. All right. How do you know this is a growth or decay problem?
It's 12% per year. That's a growth right there. Decays instead of depreciates.
Right, it says depreciates. So we know that this is going to be a decay problem,
All right. Good.
which means that we're going to have 1 minus our rate as part of the equation, right? So what is our initial value?
It's 12%. What?
Thank you, 16,000.
Sorry.
All right, then it's going to be 1 minus because it's depreciating, so it's decay. What is 12% as a decimal? 0.12 raised to the x. So again, you're always usually going to see it written in a simplified form. So $1 minus 12 cents is 88 cents. All right, that's your equation. Now they want us to find the value after how many years?
3 years.
3 years.
So you gotta do it over 3, right? The next one.
All right, so let's see. We've got 16,000 times 0.88 raised to the third. So after 3 years, the car is worth $10,903.55.
How would you do that on what's your car with that much? How much? Imagine paying that in real life. $10,000.